So 10.5 is all about more probability stuff, more specifically permutations and combinations. So the difference between the two is that in permutations, the order matters. So a permutation is an arrangement of objects in which the order is important. For instance, the 6 possible permutations of the letter A, B, and C are shown. So example 1 says, consider the number of permutations of the letters in the word July, and how many ways can you arrange all the letters? So in the word July, there's how many letters? 4. How many different possible letters can we put first? 4 different possible ones. We can put J first, U, L, or Y. Let's say we put J first. How many different possible letters can we put second? 3, because then we only have U, L, and Y left. Let's say we put U second. So then how many different possible letters can we put third? 2. And then last we would have 1. And to find the number of permutations, we just multiply these together. So 4 times 3 times 2 times 1. What would that be? 24. So there's 24 possible ways we can arrange all the letters. Now if we're just arranging 2 of the letters, we're doing the same thing, but there's only 2 spots here. So how many different possible letters can go first?
2.
We have 4 letters to choose from. We're still picking from July, but we're taking 2 of them. So how many could go in our first spot? 4. And how many can go in our second spot? 3. So we just have 4 times 3 here, which is 12. So there's 12 different ways we can arrange 2 of the letters. All right, let's do 2 more down here. And how many ways can you arrange the letters in the word house? So how many letters total do we have in house? 5. 1, 2, 3, 4, 5. So how many different possible letters can we have in our first place here? 5. So let's say we put H first. Now how many different possible letters can we put in our second spot? 4. And then 3, and then 2, and then 1. Multiply all of these together. What do we get? 120. All right, and then the last one on this page, let's look at number 2. And how many ways can you arrange 3 of the letters in the word March? So we're only picking 3 of the letters, so we have 3 spaces here. March has how many letters total? 5. So how many different possible letters can go in our first spot here? 5. What about the second spot? 4. And the third spot? 3. So 5 times 4 times 3. 60. All right. So we actually have a formula for permutations. So the number of permutations of n objects is given by this. Or if we have the number of permutations of n objects and we're only taking r at a time, it's given by this formula here. So this is like when we had house, so the house example where we took all 5 letters. This is like the March one where we only picked 3 of them. All right, so let's look at example 2. 10 horses are running in a race. In how many different ways can horses finish first, second, and third? Assume there are no ties. We know this is permutations because in a race, the order matters. It's different if you get first, second, or third. Just one of our examples of permutations are races, and anytime you see an example with race, you know you're going to use the permutation formula. So we have how many horses total? 10. 10. So our n is 10 because there's 10 objects that we're looking at. But we're only looking at how many places? First, second, and third. So 3 places is all we care about. So the formula we're going to use is 10p3. So n is 10 and r is 3. So we have 10 factorial on the top over 10 minus 3 factorial. Now that factorial, I know we haven't done it this year, but you've probably seen it before maybe. So that for factorial, that exclamation point, it's not just like a loud 10. It's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's whatever that number is and everything after that. On the bottom, we have 10 minus 3 factorial, so that's 7 factorial. So that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now we could put all of this on the top in our calculator and all of this on the bottom in our calculator and divide and see what we get. But a shortcut and a way that we can kind of eliminate some mistakes is by crossing out anything that's in common on the top and on the bottom. So what number do we have in common on the top and on the bottom?
7, 6, 5, 4, 3, 2.
7, 6, 5, and everything after that. 4s, 3s, 2s, and 1s. So what are we left with?
10, 9, and 8.
10 times 9 times 8. So then we can just put 10 times 9 times 8 in our calculator.
720.
720. So there's 720 different ways that horses can finish first, second, and third. All right, let's look at 3. In example 2, suppose there are 8 horses in a race, and how many different ways can the horses finish first, second, or third? So what's our n now? How many objects are we looking at total? 8. And then our r, the places that we care about, what would our r be? 3, because we only care about first, second, or third, the 3 places here. So our formula is going to be 8p3. So we have 8 factorial on the top, and then 8 minus 3 factorial on the bottom. So that factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 minus 3 is what? 5. So on the bottom, we have 5 factorial, which is 5 times 4 times 3 times 2 times 1. Do we have anything that cancels out on the top and on the bottom? 1s, 2s, 3s, 4s, and 5s. So what are we left with? 8 times 7 times 6. And what's 8 times 7 times 6? 336. Do you all agree?
Let's get 720.
Right, so if we did it like the same way that we did example 1, so there's 3 places that we care about, first, second, and third. We have 8 different horses that could go here. If, let's say, I don't know, the rainbow horse gets first, that first place horse can't also get second place, so then we would only have 7 different horses that can come in second. And then if the blue horse gets second and the rainbow one gets first, they can't also get third place, so then we only have 6 possible options here. So it's 8 times 7 times 6. So yes, it's the same thing. You could do it either way. All right. Next, let's look at combinations. So the number of combinations of n objects taken r at a time is this formula. So in combinations, the order does not matter. So count the possible combinations of 2 letters chosen from the lists A, B, C, and D. So we have 4 letters total. So N is 4. And we're only asked to pick 2 letters. So R is 2. So we have 4, choose 2. So on top we have 4 factorial. On the bottom we have N minus R, so that would be 4 minus 2 factorial times 2 factorial. So 4 factorial on top would be 4 times 3 times 2 times 1. On the bottom, 4 minus 2 is 2 factorial, so 2 times 1 and 2 times 1. Everybody sees the first 2 times 1 came from this, and then the second one came from this. Everybody with me so far?
Yeah.
Does anything on the bottom cancel out with anything on the top? The 2 and the 1, so we can cancel out these 2's and these 1's. Can't cancel out more than 1 2 with just 1 2 on the top. So we still have a 2 and a 1 on the bottom. But 2 times 1 is just 2, so you can kind of just ignore the 1's. You don't really need them. Can we cancel out anything else?
No.
Does 2 go into anything on the top? 2 goes into 4, so we can take 2 out of the 4 and we're just left with 2. So then on top we just have 2 times 3, which is 6. And on the bottom we have 1, but 6 over 1 is just 6. So you could do it this way, or if you didn't cancel those out, you would have 4 times 3 on the top over 2, which would be 12 over 2, which simplifies to 6. So you don't have to simplify everything. Just make sure you simplify at the end. So I'm going to go back and read this little paragraph about combinations, kind of just to help us get a better idea of the difference between permutations and combinations. So a combination is a selection of objects in which the order is not important. For instance, in drawing 3 identical prizes, you would use combinations because the order of the winners would not matter. So that's a difference between permutations and combinations. In permutations, first, second, and third are 3 different places. It's different if you get first place or if you get third place. In combinations, it would say that there are 3 of the same prizes. It wouldn't distinguish the difference between the 3 prizes. So if the prizes were different, then you would use permutations because the order matters. So let's look at number 5. Count the possible combinations of 3 letters chosen from the list A, B, C, D, and E. What would our N be?
5.
5, because we have 5 different letters to choose from. What's our R? How many of the letters are we picking? 3. So we have 5, choose 3. So on the top we have 5 factorial over, on the bottom, 5 minus 3 factorial times 3 factorial. So we have 5 times 4 times 3 times 2 on the top. I'm not going to write the 1 because we don't really need it. 1 times anything is just that thing. So on the bottom, 5 minus 3 is 2, so 2 factorial would just be 2 times 1. Again, I'm not going to write the 1 because we don't need it. And then 3 factorial is 3 times 2. What can we cancel out on the top and on the bottom? The 2's and 3's. And then we could also take out 2 from this 4, and we're just left with 2. So on the top, we have 5 times 2, which is 10. So there's 10 possible combinations. Let's look at example 5. You order a sandwich at a restaurant. you can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? So what's our n? 8. And what's our r? 2. So we have 8, choose 2. So 8 factorial on the top, 8 minus 2 factorial times 2 factorial on the bottom. So on the top, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 8 minus 2 is 6. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. So what can I cancel out on the top and on the bottom?
3 and 2. Oh, wait, 6, 5, 4, 3, 2.
I can cancel out the 6s, the 5s, the 4s, the 3s, and the 2s. So on the top, I'm left with 8 times 7, and on the bottom, I'm left with a 2. I could cancel out the 2 and take out 2 from 8, so I'd be left with 4. So on the top, I just have 4 times 7, which is 28. So 28 possible dishes. All right. Number 6, we're finding a probability using combinations. We're doing the same exact thing, but probability is like a fraction, like we did in the last section. The only difference between example 6 and example 5 is that when it asks for probability, it's always going to be 1 over the number of possible ways. So whenever it says probability, you need it to be a fraction, so it's going to be 1 over the total number that we just found using our formula. So it would be 1 over n choose r, like this. So we're still using that combinations formula, we're just putting it into a probability problem here. So let's look at our question. A yearbook editor has selected 14 photos, including one of you and your friend, to use in a collage a collage for the yearbook. The photos are placed at random. There's room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? So what would our n be? What's our total number of pictures we have? 14. How many do we want? 2. So we have 14, choose 2. So 14 factorial over 14 minus 2 factorial times 2 factorial. So on the top, we have 14 times 13 times 12. I'm going to stop there, and I'll show you why. So this is 12 factorial, because I could keep going. 11 times 10 times 9 times whatever. Just keep going. But I'm going to stop. Because on the bottom, what's 14 minus 2? 12. So I'm going to have 12 factorial on the bottom. So I know that this 12 factorial here and this 12 factorial here are both 12 times 11 times 10 times 9 times 8 times 7. And since I have one on the top and one on the bottom, they're going to cancel. And I also have 2 factorial, which is just times 2. So on the top, I'm left with 14 times 13, and on the bottom I have 2. I can do a little bit more simplifying because I know 2 goes into 14 7 times. So on the top, I actually just have 7 times 13. What's 7 times 13? 91. And since this question is asking about probability, it's going to be 1 over 91. All right, 2 more. In example 5, suppose you can choose 3 side dishes out of the list of 8 side dishes. How many combinations are possible? So in this one, number 6, Are we using permutation or combinations? Does the order matter?
No.
The order does not matter, so that would be combinations. What's our n?
8.
8, because we have 8 total. And then how many are we picking?
3.
3. So 8 choose 3. So we have 8 factorial on the top, 8 minus 3 factorial times 3 factorial on the bottom. So on the top, I have 8 times 7 times 6 times 5 factorial. I'm going to stop there because I see on the bottom that, what's 8 minus 3? 5. So I have a 5 factorial on the bottom, which I know that's going to cancel out with my 5 factorial on the top, so I'm just going to save myself some time so I don't have to write it all out. And then I have 3 times 2 times 1. So anything on the top cancel out with anything on the bottom?
The
5
5.
factorials. Anything else?
No.
And 3 and 6.
What's 3 times 2?
6.
6. So I can cancel out the 3 and the 2, because 3 times 2 is 6 with the 6.
Oh, so you can do that?
Yeah.
Probably not.
Because 3 times 2 is 6, so this is 6 on the bottom. So I'm canceling out the 6 on the bottom with 6 on the top. So on the top, I just have 8 times 7. What's 8 times 7? 56. So 56 possible ways. Any questions there? Ready for number 7? All right. In example 6, suppose there are 20 photos in a collage. Find the probability that your photo and your friend's photo are the 2 places at the top of the page. So how many pictures do we have total? 20. And how many are we choosing? 2. So 20 choose 2. So we have 20 factorial on the top over 20 minus 2 factorial times 2 factorial. So on the top, I have 20 times 19 times 18 factorial, and I'm going to stop there because I see on the bottom, what's 20 minus 2? 18. So I have 18 factorial on the bottom times 2 factorial, which is just 2 times 1. So anything on the top cancel out with anything on the bottom?
The
18 factorials. Anything else? 20 and the 2. So 2 goes into 20 how many times? 10. So then on the top, I just have 10 times 19, which is 190. This question asks for the probability. So how am I going to leave my answer? 1 over 190.